we have a matrix here, 4, 3, minus 3, minus 6. We've been through the process of finding the eigenvalues for it, which was negative 5 and 3. And now what we're going to do is find the eigenvectors. So if we go to the next page, what I've done is I've written out this matrix again on the next page, and I'm going to use the first eigenvalue, which was 3. And I'm going to put that in. Lambda equals 3, so I'm going to put that in to give me the matrix minus 1, minus 3, 3, 9. And I want to multiply it by its eigenvector, which I'm going to call AB, and I'm going to get the 0 vector out. So this comes out as being 0, 0. Now, the conventional way would be to do this and make a simultaneous equation. So it would be minus A minus 3B equals 0. Or of course, we could turn that into A plus 3B equals 0, just to get rid of those minuses. And the second equation is this one times this one. So we have 3A plus 9B also equal to 0. Now this actually doesn't really help me, because the second one, and this will always happen, is just a multiple of the first one, so it makes it difficult to solve. So what I'm going to do is I'm going to find some general values. So I can, for example, make A equal to 3, and in this case, B would have to be negative 1 to make it work. And I can actually find a whole set of values like this. So I'm going to call this eigenvector 3, negative 1, and I can have any multiple of that, so I call it T. So here's my first eigenvector. But of course, I have another eigenvalue, so I do the same again, and I make this one equal to negative 5. So that's my other eigenvalue. So the vector becomes negative 9, negative 3, 3, and 1. And again, we're timesing it by this sort of matrix AB, and we get the 0 matrix, 0, 0. And again, we end up with two equations with two unknowns, but they're one equation of each other. So let's just take the second one, 3A plus B equals 0. So I'm going to make A equal to 1, and if I make A 1, B has to be negative 3. So it's 1 and negative 3, and we have T multiples of that. So this is my second eigenvector. We're going to use these vectors to make a diagonalization in a minute of A, but what you need to do is to do plenty of practice in finding eigenvectors before you do the next bit.